So now we can see a problem in the domain of technical diagnosis of car fault example. So here you can see we have a new problem that is we need to solve. So the problem was is black brake light does not work. So we have some value, the car model, year, battery, and light is okay or not. So this is a new problem case that we need to solve. So let's see what and how we can solve it, and how a CBR solves problems. So like the new problem can solve by using the old problem and maybe adapt to the new solution. So the same action execute under the same condition will train to the repeat themselves. So that means here you can see that the problem and solution, they are associate each other, and if we have a similar problem, then we can also have a similar solution space. So experience tend to repeat themselves, that we know, and small change is needed, of course, if it is need an adaptation. So here in the picture you can see that how they are used to solve the problems. So once a currently encountered problem is described in terms of previous solved problems, the most similar solved problem can be found. The solution is to this problem might be directly applicable to the current problem, but usually some adaptation is needed or required. The adaptation will be based upon the difference between the current problem and the problem that serve to retrieve the solution. Once the solution to the new problem has been verified as correct, a link between it and the description of the problem will be created, and this additional problem solution pair, the case, will be used to solve new problems in the future, so they will be retained. Adding of new case will improve the result of a CBR system by filling the problem space more densely. So as we said, mentioned that our first task of CBR approach is to retrieve similar case from the case library. So we need to compare the new problem to each case stored in the case base to select most similar case or cases. Similarity is most important concept in CBR, that is when two cases are similar, or how the case is ranked according to the similarity. So here in the picture you can see that we have a new problem and we are looking for similarity for all the cases, or from case 1 to rest of the case in the case base. Similarity of the case, that is finding a set of matching case, is done by using the problem description, that is the input features, as index to the case memory in a direct or indirect way. Similarity measures include the knowledge about the similarity measure itself and the knowledge used to choose the most efficient organization of the employed case base and the most appropriate case retrieval methods. So we can use several different kind of methods to retrieve the cases and or find the similarity. Let's see this example. If you remember, we have this problem and we have this solution, stored case, solved cases, that is case 1. So now you can see that the problem is brake light doesn't work, and here it says front light doesn't work. So they are more or less similar because both of them are discussing or presenting about the light, but one is brake light and one is maybe front light. But they are two different cars, so the similarity is less because they are not in same model. Then they have a year, it's more or less same but not that much, but battery is, you can see that very similar because it's 13.6 and 12.6 volt. So it's very close. And then state of the light is okay. Here is state of the light is also okay. So that means they are 100% match. So they are very similar. Here you can also see that there are red color arrows, and these arrows are actually shows the similarity between these features. But the thickness, you can see the thickness, they are actually representing how important these features are. So, and it can be given from 1 to 10 or even 1 to 100 and so on. It depends on how you define it. For in this case, we have said that when it is very important feature, the weight is 6. So you can see that the thickness of this arrow is little bit higher than the thickness of these two when the feature size is less important. And then here the similarity value can be also defined from 0 to 1. So here 0 means no matched and 100 means 100%, or sorry, 1 means 100% match. So in this case 1 means they are 100% match. So what we have seen now, that different features value, their weights, and their similarity value. Now we need to calculate the overall similarity between the new case and the case 1. So this is the function you can see that can be used for calculate the similarity between new case and case 1. What we are doing in here, we are multiplying each weight that is defined and their similarity value, and after that we can sum of them divided by the total weight. So what weight we are given in here with the red color, we can sum them and divide it from this value. And finally, by using this function or formula, we get a similarity value that is called 0.86. That means case 1 is matched with this new case 86%.